Hello everyone, welcome back. Let's learn about object copying or object cloning in Java. Object copying basically refers to creating a copy of an object from an existing object. There are mainly two types of object copying. We have shallow copy and deep copy. We'll also be talking about reference copy. We'll be talking about cloneable interface and the clone method, which comes from Java object class. So for this video, I have created two objects, a student object or a student class with primitive and non-primitive data types or fields. ID is of type integer, which is a primitive type. Name is a type of type string, which is object or reference type. An address is itself another object or complex type or reference type. So if we go to address, for address we have city and state, both are of type string. And for getters, setters, and toString method, I have used the Lombok annotations. If you don't want to use the Lombok library, you can manually create the getters and setter for your classes. Just press Alt and Z in Windows. You can create constructors, no arc constructor and parameterized constructors. You can create getters and setters, equal and hash code, toString, and override the methods. But for this video, let's use these annotations to make our code more simpler. And all arc constructor will generate the parameterized constructor for all these fields. No arc constructor will generate the default constructor for a student class. A data will generate the getters, setters, toString, equals method, and the hash code method for this class. And at builder, it will allow us to create objects of this class using builder pattern. So let's go to main method and let's create some objects. What I'm gonna do, I will create an address first. Let's call it S1 address or student1 address equal to new address. For city, let's give it Seattle. For state, Washington state. Let's create an object of student also, student S1 equal to new student. Let's give it an ID of 101, name Bob. Then we have height, let's give it 4.6 floating point. And address, we can pass this reference variable here, S1 address. So when we create an object using new keyword, this new keyword basically creates an object inside the heap memory, and it will return the address of that object from heap, and that address will be stored in this S1 reference variable. This reference variables will be created inside the stack memory, and these objects will be created inside the heap memory. So let's quickly print the information. Let's say S1 tab plus S1. So to print student1 information, we can see student1 have this information. Say if I wanted to create another reference variable of type student, I will say student S2 equal to S1. Right now we have created two reference variable of type student, and both these variables point to the same object inside the heap. If we wanted to bring changes to this object using any of these reference variable, it will be reflected to this both of these reference variables. So let's print S2 also here, S2 and the S2 information. It should print the same object. We have same values, and if I wanted to change I need to change the name using S2 reference variable S2.setName, it should bring the change to both S1 and S2. Let's set it to mark. Name should be marked for both the S1 and S2 reference variable. Let's see what's happening here. Let me copy these two lines of code, and if I paste it here, imagine we have a stack memory and heap memory. So when we say address equal to new address, this new keyword will create a new object of type address inside the heap memory. Okay, so let's see, here is an object of type address inside heap. It will have a city as Seattle, and it will have state as Washington State. Inside this heap memory, this object will have an address, a memory address. Let's say it has 20065. Imagine this is a memory address. But this reference variable or S1 address will be created inside stack memory. Here we'll have a reference variable S1 address, and this will store the reference or the address of this object. So S1 will store 20065, and it will point to this object. And when we say student S1 equal to, S1 will be created inside the stack, a reference variable. When we say new keyword, it will create an object of type student inside heap. Again, an object will be created here. This object will be of type student. It will have an ID, a name, height, and it will have an address. So this address reference variable will be created inside the heap memory, inside this student object. And this object also will have a memory address inside heap. Imagine this has 60051, and new keyword will return this address, and it will be stored in S1 reference variable. So S1 will hold 60051, and S1 will point to this object inside heap. And when we say we pass the address of or the reference variable of this address object to the constructor of a student, inside the constructor we will have this dot address equal to the address we pass. Basically this address will be stored in this reference variable. This reference variable will have an address of 20065, and this reference variable will point to this object. When we create S2 here and set it to S1, S2 is another reference variable. It will be created inside the stack. We will have S2 equal to S1. So S1 has this memory address. S2 will also hold this memory address 60051, and S2 will also point to the same object. So that's why when we bring changes either using S1 or S2 to this object, it will reflect to the same object. So basically we're changing the same object, not two different objects. This is called reference copy. We have not created two objects. If we wanted to make more references, we are pointing to the same object. To make a separate copy of a student and assign it to S2, what we can do is we can manually create a deep copy, manually copy the objects and return that. So what we are going to do, let's go to student class and create a deep copy method that returns a student object. Let's call it public return a student. Let's call it deep copy or get copy, whatever you want to call it. Inside this deep copy, what we are going to do, using the S1 or the current object values, we will create a new object. So in order to get a reference of the current object, we can use this keyword inside Java. Let's create a new object for all the reference variables. So for address, we will create address. Let's call it copy address or new address equal to new address. So we'll get hold of this dot get address dot get city. We pass the city first, then we will pass the address. This dot get address dot get state. So we have created a new object of type address using the S1 values or this object. Then let's create another object of type student. Copy student equal to new student. this dot get ID, this dot get name, and this dot get height, and we pass this reference variable copy address for the address here. This way we created two separate objects. We use the new keywords, so two new objects will be created inside the heap. Beside these two objects, another object of type address and a student will be created, and finally we will return the address of a copy student or newly created object, return copy student. So this way we can deeply copy an object in Java. So let's go to main. Instead of assigning the reference object, the reference of the object, what we can do, we can call this function which returns a student. So a student s2 equal to s1.get deep copy. When now we have two separate objects, we have one object that is referenced by s2 and we have another object that is referenced by s1. When we bring changes using s2, it's not going to affect s1. So let's run. Yeah, for s1 we have Bob as name as Bob, and for s2 we have name as Mark. To print the hash code or the identity of each object, when an object is created, it will have a unique ID. We can access that. Let's print the unique ID of each object using the system dot identity hash code. It will take an object and return an integer, a unique ID for each object. Let's print it for s1 and let's print it for s2. Here I'm gonna say s1 ID, and here s2 ID. They should have two different IDs. Yep, we have a different ID and different ID, but if we don't call the deep copy, both the objects and even the addresses for the both reference variable will have the same ID. Here we can see they have the same IDs, the same hash code values. Basically it means that they are both the same objects. So let's call the deep copy. And also if you want to check the hash codes of the address objects, this one you can do that using the system.identity hash code method. It is going to print the unique IDs for each object. Now let's learn about clonable interface. This was the deep copy. Manually we created the method. We can deeply copy an object using the clone method. For that we have to implement the clonable interface. Here implement clonable interface. Also for address we will also implement the clonable interface. And we have to override the clone method. Let's press Alt Insert and let's go to override method, and we will override the clone method that comes from object class. For student also, here we have to override the clone method. Alt Insert, let's go to override and override the clone method. So right now we can access this clone method through our student object to get a new object of type student. Remember that by default the clone method uses shallow copy. It doesn't deeply copy the nested objects or the reference variable inside the student. So it will create, when we call the clone method, it will create a new object of a student. It will copy these primitive types, but it will not deeply copy the reference type. For a string, although it's an object type, the clone method will deeply copy that because a string is immutable by default, and when we clone that, a new instance of a string object will be created. Although it's a reference variable or object type, the clone method will deeply copy the string values. But for custom types such as address, the clone method will shallow copy that. Because it's a nested object, it will just copy the address of the same object from memory. So let's go and create a new object using clone method this time. What I'm gonna do, I will comment out this. Let's say student s2 equal to s1 dot clone. This clone method will create a new student object. It will throw an exception, I think. Yeah, let's add the exception to method signature. It throws a clone not supported exception, and also this will return an object, but we require a student. Let's typecast it to a student. So this way it will create a new student and store it to s2. If I print that, let's see what's happening. So we can see that we have two different hash codes. S1 has a different hash code and S2 has a different hash code. Basically, it has created a new object of type student. Say we have another student object. It will copy all these primitive values here, but for address, for this reference variable address, it will not copy and create a new address object. What it will do is it will shallow copy the address value, means it will shallow copy the address of this object. So basically it will store 200065, and it will also point to this memory address. So we have two student objects right now and one address object. We have not deeply copied this address object. To verify that, let's print this out. S1 address ID system dot identity hash code s1 dot get address, and let's print it for s2 also. Although there are two different objects here, but the address reference variable, this one points to the same object. It's not deeply copied. So s2 address ID, here we'll see s2.get address. This should have the same hash code. Yeah, because they are pointing to the same memory address in the heap. So here I brought changes to name. For the student one, name is Bob, and for student 2 it's Mark. This means that we have two objects. If I wanted to say s2.set id 202 or 201, it should only bring changes to s2, not to s1. But if I wanted to bring changes to address, s2.get address.set city to Spokane, it should change the city for the both objects, because they are pointing to the same object. In order to deeply copy an object using clone method, what we are going to do, it was shallow copy. Let's put it here. We covered shallow copy also. By default, remember that clone method does shallow copying for the reference variables, not deep copying. In order to deeply copy an object using clone method, we have to manually clone each reference variable inside this object. So inside this clone, what we are going to do, first let's clone the student object. Instead of calling the super, we'll say student cloned student equal to super.clone. It will return an object, I think. Yeah, we have to cast it to student. So this way we cloned the student, and now let's clone all the reference types or reference variables of the student. Right now we have only one reference variable, so we are going to clone the address. Let's say address, cloned address equal to super, or this cloned student dot clone dot get address dot clone dot get address dot clone, and let's typecast it to address. And finally we set this cloned address to this cloned student. So cloned student, the set address of cloned address, and finally let's return the cloned student. Let's go to main and run our project. Yeah, we have right now we manually or deeply copied the object using clone method. We can see we have S1 and S2 has two different identity hash codes, and also S1 address and S2 address also have two different identity hash code. Here when we set s2.getAddress.setCity to Spokane, it's going to change the city only for S2, not for S1. So here S1 city is Seattle, it's not changed, but S2 city is Spokane. What happened, basically what we did is we created another object of type address. Let's say this is another address object, address. It will have an address of, imagine a memory address of 2166. It will have city and it will have a state. And this reference variable, instead of pointing to the same object, this is S2, it will point to this newly created address or 2166. It will point to a separate address object. So this is all about cloning and object copying in Java. Hope you guys have learned anything. Thank you guys for watching, and see you in the next video. Bye bye.